So I'm sharing the screen. If you remember, when we did the NumPy exercises, we would start here. Okay, so we can do conda environment list. All right, and for this class, it should be 537 ITS 365. So I'm going to activate that environment. 537 ITS. All right, also, I'm going to navigate to the folder. Do dir, cd desktop, dir, cd, ITS 365. Okay, great. So what I'm going to do first, as I start writing the code, is I'm really going to fill in like a skeleton of kind of the steps that we would follow, right? So this is this section for that. And then we're going to start to fill it in. And then kind of the last thing we will look at is our KNN algorithm. Okay, so to implement it basically, and I have to give you some ideas as to how that works. So it'll take a while. Okay. All right. So let's get. So, all right. So this is where I'm going to create the script. So now we can start Jupyter Notebook. Okay. All right, so let's, as I said, let's start with just the idea of the main ML pipeline. What is this going to look like? So I will, provide the sections that we should have available. All right, and some of the things that we had in Weka, we're going to have here like a confusion matrix, precision, recall, F measure, etc. All right, we just, one good thing about this is that this pipeline is kind of consistent. We just keep adding more to it. All right, so let's create a new script here. So I'm going to call this one ML pipeline action. And then maybe we can add the KNN part later. There's a lot of ideas. So instead of me giving you all the formulas and everything, let's start with the code. And then once we have questions about what everything is, we can drill down into the specific equations. You'll see how this is all based on like Pythagoras, right? Do you guys remember that? The Euclidean function? Those two things are basically what make this possible, okay? And you'll see how that works. All right, so now not all algorithms, I should say, KNN is not a neural network, for instance. So although they do have some things in common, not every algorithm, just because I'm saying that, the way that I'm describing KNN doesn't mean that that's the only machine learning algorithm. There are other ones that are very different from KNNs. There's probabilistic ones, Bayesian ones, there's going to be neural network ones, okay? So this is a very specific type of algorithm. All right, so let's go ahead. I'm going to rename this file. I'm going to call it ML pipeline. Okay, I've specified that. I'm going to put in a comment here. I like to, these are notebooks, so you can put whatever you want, equations, etc., pictures. So I'm going to say machine learning pipeline. Okay. Markdown, and I'm going to hit run. So that makes that cell, as you remember, a cell that does not execute code. It's just a comment. All right, so I usually have a section, several sections. I'll have one for installs. Okay, so you can actually install libraries from here. So I'll do something like this, and then pip install, and then maybe like, I don't know, matplotlib, etc. Right? So you can install any libraries. We'll install Torch later on, etc. Right? So you can leave that there as a comment. Then here, I'll usually have the libraries. Okay, so in this case, let's just for now import the one that we're familiar with, which is NumPy. And the goal with a lot of these, the reason why we want to implement them in NumPy is that it helps us to better understand the algorithms, okay? But later, if we're using something like Torch, etc., it's going to abstract a lot of the details. Okay, so that's usually the library section. Then we have the parameters section. Okay, so here we can add specific values. Right now we won't really have that many parameters. Maybe the only parameter that we're going to have is hey equal 5. Going to make this a comment action. Okay, just like that. All right, then after that, we want to have maybe the data, process the data. Okay. Then somewhere on here, we're going to have the algorithm. So in this case, KNN, we're going to define it. Okay, and finally, we have to do the performance analysis. Okay, so we're going to say performance. So usually to do performance, I'll show you how to calculate the accuracy by hand, kind of, but we'll be using sklearn really to be able to compute the values for classification or regression. Okay, so let's go ahead and get started here. Okay, performance. So here then, all right, so the first thing we want to do, we know that K is equal to 5, right? So that's the number of neighbors that we're going to use. So the KNN algorithm is basically a vector space model, right? And what does that mean? It means that it's a space. It's literally like a geometrical space. Yeah, go ahead.
Vectors and vector spaces are kind of like vector spaces are kind of like functions, but for vectors.
We can apply functions in that space. Okay. So a good analogy is this room. This room has how many dimensions?
Based on how many points?
Yeah, how many dimensions are here? It's 3D, right? There's 3 dimensions in here. So I can say Quentin's over there, right? And Henry's over there, right? So within this space, I can say that you're kind of far away from Quentin. What's your name? Huh?
Brock.
Brock. But Brock is closer to Quentin. Do you guys see that? So as long as I can create this space, then now I can have distance functions within it. You see that? So samples, what we when we're creating the machine learning data set, right? We have the X, which is rows and columns. So rows are samples. So you can think of all of you here as samples. So you're all basically a row in a data set. And now what you can do it with KNN is that you can compare your distance to other samples. And that way you can start to say, okay, I'm closer to this, or, and so on. Does that make sense? So then when now if you label, right, the samples, now you have one label for the people over there and another label for the people over here. So so let's say this is all of you on this side are class 0 and all of you on that side are class 1. So now if I'm a new element in this space, am I closer to the samples that have class 0 or the samples that have class 1? 0, right? I'm closer and the majority of you are 0. That's KNN basically. KNN is an algorithm where the new sample goes into the space and now it compares itself to all the other samples. That's why it's called lazy, because it always does that. You don't learn like an optimal way of doing that. You just always compare yourself to everything else. You figure out who are the K closest to you. So in this case, I think 5 is the 5 closest samples to you. So 1, 2, 3, 4, 5. And you're all 0. So then I just take the average of that. That's the class. So now if somebody comes in at the door over there, are they class 0 or class 1? Class 1. Does that make sense? What if somebody is like right in the middle of this room? Like right there, like under the projector basically. Are they class 0 or class 1? It would be very hard. Oh, actually, no. So 1, 2, 3, 4. 1, 2, 3. There's a missing chair over there. Do you see that? Missing chair. So possibly then it would skew to that side, and that's 1. You see that, but it's a much harder decision. Yeah.
I get the, like, from me to him, like, coordinate. Like,
Yeah.
First coordinates me, subtract that, you get the vector.
Yes.
I don't get how you, like, are you just dividing that in half?
You look at the 5 closest. So basically, you take the element and you calculate the distance between that element and everything else in the space.
That'd be the magnitude vector, right?
Just the distance, yeah, the distance between, like the Euclidean distance between 2 points in a vector space. We'll see all of that, so don't worry about it. But yeah, so we'll look at that for sure. And you just have to then calculate all those distances. You can really already start to think about this algorithm, which is what I'm describing. Give me a sec. So bring the data point. There's a function called a Euclidean distance. Calculate that distance between you and every point, right? And you start maybe over there and you end up over here. Then what's a good idea? Once you have those distances, then what should you do? Sort them from shortest distance to largest distance. Then what? Just pick the top 5 of those. And then out of that, take the average. That's KNN. Does that make sense? That's the whole algorithm right there. You just implemented a machine learning algorithm. Okay, so obviously we're going to implement this in the code and we're going to see, and it should work. Yes.
How many dimensions is the vector? Like,
how many dimensions, right? How many? That's actually where I was going to. How many dimensions are in this vector space? So in the real world that we live in, there's 3 dimensions, right? So I used this example, but we need a machine. We need vector spaces that actually can represent more dimensions. Why? Because really the way that that X, going back to X again, right? We have the rows and the columns. The columns are the features which roughly dimensions. Okay, so I think we're back.
and the length of a vector is the square root of.
Henry, we're going to look at all of that. Don't worry about it. I'm just kind of laying the idea right now. Okay. Does that make sense, guys? So the point to remember is that although we're used to 3 dimensions and we know how to take a distance between in this space, you can imagine spaces that are larger than 3 dimensions, where we have a 4th, 5th, and 6th dimension. So Iris, for instance, right, has 4 dimensions because it's got 4 features. And you can just think of axis 1 as feature 1, right? Axis 2 as feature 2, axis 3 as feature 3. But what about feature 4? So you can add an axis 4, which represents feature 4. Mathematically, that holds, okay? So then we'll be able to use the Euclidean distance like that. All right, we'll come back to that idea. Don't worry. So, but for now, let's start with the implementation. Okay, so let's take a look at KNN. And I do have some slides. I'll go to them in a while. All right, so once we have this, we need to get some data, right? So we're going to use sklearn. So I'm going to now import a new library called sklearn. So I'm going to do from sklearn import data sets. All right, let me run this. Okay, it runs. Oh, nope. Okay, so if we have this problem, what does that mean? It means we haven't installed a library. So we just can do this. It's like that. All right. All right, so it finished installing. Okay, so now we should have this library available. Hit run. I'm gonna try it again. All right, great. So we have it. That means it ran, we have it available. So we are going to bring in Iris into our Jupyter node. Okay, so let's do Iris equal data sets dot load Iris. Okay, so it worked fine. Errors. Let's add a few more here. Okay, now remember those word problems, right? What is X? What is Y? I kept stressing how important that was. This is Y. It's always X and Y. Okay. So we're going to bring in our data. So you already know what this means just by me writing matrix X or, uppercase X and lowercase Y. So I'm going to do here iris.data. And I'm going to do iris.target. And this is just an example. We will later read in the CSV also. So let's run that. Okay. See that? Now let's run X. And guess what? There you have it. You have your data set brought in, the X, as we were talking about. Okay. We can also do that for Y. And it's right there. Now, how many samples are here?
And those are the labels, right?
These are the labels, yeah. 1, 2, 3, 4. Actually,
It's not a regression. It's a real number. Or
it's 150. So there's 100. No, these are so Iris is for classification. Okay. There's only 3 labels, right? So if you notice, there's 150 samples here. If I print Y, it's 0s, 1s, and 2s. Regression would mean that there's a lot of numbers like temperatures, 32, 77, 86. We're trying to predict a lot of things. In classification, we're only trying to predict 3 things. Whether these iris flowers are setosa, virginica, or versicle. Make sense?
classification would be like a fixed number of a sufficiently small size.
Discrete. a discrete list of options, basically. Like 10 classes,
The
3.
binary is just two.
If it was a binary classifier, we just have 2 classes, yes. Any other questions? All right, so let's run type y. So it's a NumPy array, all right? So I want to know that it's a NumPy array so that I can process it as a NumPy array. Make sense, guys? All right, once I have the data, what did we do in Weka, right? So we read the data. We wanted it to be like this. Basically, we've looked at it. Another thing we might want to do, I like to do this all the time, is print the shapes. That's actually really useful for me because I know there's 150 samples there and 4 features, right? And I can do the same for Y. Y shape. I have that 150. Okay. Now, what do we need in machine learning? In machine learning, we need to train a model and then test the model. That's kind of what we always need to do. So that means we need to split the data into usually the train set and the test set. Some people do train set, validation set, and a test set, so 3. But in general, for the most part, I usually just do these 2. The validation would be like when you're training and you're kind of during the training looking at the performance and the validation set, but then you still want to, once it's fully trained, you want to look at how it performs on another data set. Or if it was like a competition, that's the held out data set that everyone's going to compete on. Got it? All right. So the next step then is really, since we have to always train and test, right? We're going to split the data, right? So in Weka, it was pretty easy. We just did a little thing. Here, we're going to use the sklearn, another sklearn function, right? For this. So these are the kinds of things you don't usually do manually. You can just do this using some of the built-in libraries. So in this case, I'm going to do from sklearn. Remember, this is not the algorithm KNN. This is just a machine learning pipeline in general. So I'm going to do from sklearn dot model selection import a function called train test. You'll use this a lot. All right. So that's, let's see if it's available. Let's just hit run. Okay, no errors. So the little dot is now the light background. So now we can go over here and split our data. So we need to split X and Y, right? So we need to have a train X and a train Y, right? And then we also need to have a test X and a test Y. Yeah, please.
The name reported train profile.
Yeah, it was this one. That one. Yeah. And all this is in the GitHub, so you can always just, yep.
So good question. Can we also just do import Sklearn as SN or something? Just like do SN dot whatever.
You
Or
could.
like, is there like libraries, like functions that override 12 behaviors?
What do you mean? I mean, you could do as my split or something. Is that what you mean? Do that. And then just do,
or just like import Sklearn as SN or something. Like you did with the or
yeah, you can, of course. Yeah, from SK, import sklearn as SK. Yeah, you can totally do it. This is just, you'll see this a lot.
I was just wondering, like, if I do that, will you get dot ports or something? I don't know.
Yes. How about that? No, so yeah, don't worry about that. Okay, so this is just, there's a lot, so it's Python. There's a lot of ways of doing, the same thing, right? So there's a lot, you have NumPy, TensorFlow, and PyTorch. they all do the same sometimes. Okay, so there's a lot of options. These are just the general ones, the ones that work really well. In any case. So right now we want to split the data, right? And we will usually, we have the data as X and Y, but we're going to split it into actually 4. So that's the point I'm trying to make, because we need for the training process, we need the X and the Y, and for the testing process, we need the X and the Y. You guys follow? All right, so let's go ahead and try to do that. And we will do this a lot. So as I said, don't worry. I mean, all of this will become very repetitive by the end of the semester. Okay, so train test split is the function we're going to call. So that's train test split. Okay, this takes us input X, comma, Y, right? And you should know what this is, you know, the samples and features and the samples and labels. Okay, that's all in there. For KNN, we don't have to one-hot encode the data. That's something that we do for neural networks. But for KNN, you can just use the values as is. Okay. Okay, so after that, we need to specify the split size. So I'm going to do test, it's going to be test size. And then you can specify a percentage. So for instance, let's say, yeah, 80 to 20. Yes. So I'm trying to work out the math. So it's 100, so 30 is 20, right? So 0.20. Okay. So you just specify the test size and it'll infer obviously the train size. And then here we can do random state. And here you can, if you want to be able to always do the same splitting, a random split, then you can specify a specific number. So 42. So this allows you to be able to repeat the same split. Otherwise, it would like randomize it in different ways and you wouldn't be able to replicate exactly, right? But if you specify the number, you can replicate it. Make sense? All right. So now this function is going to return 4 matrices, and they're going to be in a specific order. Okay, so this is always going to be like this. So it's going to be X train. Now, by convention, people use uppercase for the matrix, lowercase for a vector, right? So the Y should be lowercase, the X should be uppercase. Okay, yes, please. Just by convention, the X is uppercase and the Y is lowercase. Because X is a matrix, so whenever something is a matrix, rows by columns, you make it uppercase. Y is a vector here, right? So it's a n by 1. Yes.
What exactly does train test split do?
We're splitting this X and Y into 4. So that's 2, right? So we have a X and a Y, the iris data, and we're randomizing it and then splitting it into data for train and data for test.
Okay, so yeah, sorry. Okay, so X would be the vector features.
Yes.
Y would be labels.
Yes, exactly. It's exactly your homework of word problem. So it's rows by features, rows by labels.
And okay, so we're doing okay. So you're splitting to okay. So sorry. Splitting to 4. What were the 4 things again?
That's yeah. So
I'm sorry, I'm confused about the function.
right. No, I'm so just let me finish it and then you'll see it. So what I'm doing, I'll print all the shapes and then we can see, right? So I'm taking X and Y, all the data. So we had iris as think of it as iris was 150 by 5, right? But then we split it, if you will, and got 150 by 4 and 150 by 1. But I need to use some of that data to train the model and some of that data to test the model. So how do I do that, right? And so what I'm going to do is I use train test split to split that data into X train, Y train for training, and X test, Y test for testing.
Gotcha.
All right.
It doesn't really matter how it gets there.
Well, that's the beauty of it. Train test split. As long as you give it X and Y, proper X and Y, it'll give you the proper X train, and so you don't have to worry about it. Otherwise, if I asked you guys to do this from scratch, believe me, you're going to spend a few days splitting that up, okay? And because you have to randomize it and you have to make sure that things are correct, okay? So here, the function just does everything for us. So it's going to return X train, X test, comma, Y train, comma, Y test. That's it. And it always does it in this order, okay? So basically it returns 4 elements given these 2 elements here. Okay, so I'm going to run this one. And it run fine, so I'm going to add a few more cells. And now we want to visualize the shapes of these. So I'm going to do print X train. You don't always have to visualize this, but in this example, I will. Print.
Next to
Yeah, it is capital. Y train dot shape. Print X test dot shape. Print Y test dot shape. Do you see that? So now if we print these, we have 120, 4 in X, right? That's 120 samples of 4 features, and it's corresponding 120 labels. This is the data that we're going to use for training. Then for testing, once the model is trained, we have 30 by 4, so that's 30 samples and the 4 features, right? We're going to give those to the model, and the model is going to predict labels. How many labels? 30 labels. And then we're going to compare the predicted labels to the real labels, which are stored here. And that's how you get your performance. So our performance will be out of these 30, if we give it the feature vector, how many does it get right? You guys see that? That's it. So that's the performance of it. Okay, so we always do this. We always split the data. So it'll become familiar. Okay. And but if you have questions, please go ahead and ask. All right, so for now, I'm not going to write the KNN algorithm, but let's just imagine that here we would have, let's just think of how it would work. How about that? We might have a function called myKNN, for instance. So myKNN. So in general, we want to write functions. Okay, we want to have a function that we invoke somehow. And in fact, we want to get into the habit of creating this model. Okay, so this is like good practice. You always have a model, and then later on, it's going to become more object-oriented. So it's going to be a class definition that we're going to instantiate, something like that. But for now, just a function will do. All right, so we assign a function, and the function then would, basically that we have this model prediction, or sorry, model as an object, let's say, or something along those lines. And then we can think of model.train, right? All of this is code we have to write, by the way, right? So I'm just kind of showing you the main ideas. So basically we would train first, right? The model. What would we train the model on? We would train it on X train, comma, Y train. Do you guys see that? This is for training. Yes, exactly. We just train the model with this data, the 120 samples. Okay. Once the model is trained, then what do? We can use it to predict, right? So then we're going to say model.predict or something like that. What do we predict? What do we give it here? And then what does it return? So in this case, it'll return ypred. Do you see that? It'll return ypred given what? X test. You guys see that? So the model, once it's trained, it evaluates on the test set and it provides predictions. So then once you have that, how do you measure performance, right? So let's think of a function called accuracy that we also need to define, or use a function some kind. And accuracy will, is basically this function, maybe it returns something. Now, the question is, how do we measure accuracy, the performance of the model? What do we look at? Yeah.
False positives, false negatives, true positives, true negatives.
Yeah, sure. There's a lot of, yeah, you're right, actually. But what are the inputs to something like this? What do we need to actually begin? We need to have what? The predicted values, right? Which are in YPred. And what do we compare those to?
The actual.
And what is that?
That would be test what? That would be Y test.
Y test, exactly. That's it. You guys see that? That's the basic pipeline. What I'm showing you is the flow of the data through the different functions, if you notice, right? So we started with something like iris over here, right? And however we read this, it's going to come from a CSV or somewhere like that. We make it into X and Y. Do you guys see that? We make it into X and Y. This is pretty standard. You'll look at the shapes for sure. Then we have to split it. And we can split it into our 4X train, X test, so on. Then we're going to use X train, Y train down here to train our model. You see that? We train the model. Once the model is trained, we can predict on all of X tests or maybe just one sample. We want to make a model that can, that's why we use NumPy, right? So it can take a whole bunch of samples at once, a matrix, or just one. And then once we have YPred, we compare it to Y test.
Go to the split test thing.
Mhm.
The random state equals 42.
Yeah,
Is that just like the seed?
it's a seed, yeah.
Okay, and we're saying a constant be replicated.
Replicated, exactly right.
What's the test size?
Test size is the split. So 20% for test, 30, and then the rest 80% for train. Yeah. Any questions, guys? Making sense? What's great about this is it's pretty much always like this. Okay, we always follow this approach. And then what starts to change is, obviously here we have, a lot of work goes into getting the data like this. So in data science and machine learning, you'd never, usually don't have the data like this. You have to go in and collect it somehow and then fix it so that you get it to this point, iris. That's what the work problems were about. You saw them, they were kind of challenging. You were trying to create that iris, and also basically get as far as here, X and Y. Okay, once you have the data in that format, then you can go ahead and do the train test split. And then the algorithm of your choice comes in here. KNN, could be naive Bayes, could be a neural network, deep learning, whatever it is, right? That goes basically in this section, and it's always train and predict. And then once you have that, you do the evaluation. Does that make sense, guys? That's the basic machine learning pipeline. So now what we're going to do is we're going to start to drill down into these individual functions to be able to get this to work. Any questions? Now, another thing that you might want at this point is, it's nice to get data from something like this, but you're really thinking, okay, but my data is going to come from a file, right? So you're going to collect your data. So that's the next thing that we're going to do is now we're going to read in the data from a CSV file. So you can see everything from beginning to end. Okay, so there should be a file. Yeah, on the GitHub, if you guys go to the GitHub, there should be a file there.
CSV file is just separate vectors, right?
Yes. So if you go to the repo, Machine Learning Foundations, right? I provided the link on Brightspace. believe, and resources. Yeah, so there's the GitHub link. All the code is here, right? So you can just get it from there. Okay, so I provided this file, iris.csv. Okay, so now the next code segment will be to read in our data from that CSV. We can click on it and we can take a look, and you can see it's got pretty much, it's the same iris data, 150 rows, right? 4 features. There they are. And we've got the labels. Okay. This is also like the data you're getting from for the WECA homework. So very similar. Okay. So what we have to do now is read in this data into our Jupyter notebook. So I already have this file on my desktop. So let me actually just move it to have it in, yeah, Iris CSV there. Okay. All right, so I'm just going to move this file in here so I don't have to put in a full pass, okay? And then obviously that file had some, it's problematic, right? It had some like the labels are words. So we're going to have to go through that whole process of cleaning up the data. So now you start to suffer, right? The realities of data science, right? That you have to clean the data, get it ready. But you can see it, you always know now X and Y. I need to get my data to X and Y to be numbers. So how do I do that? All right, so let's go ahead back to the Jupyter Notebook over here. So we're going to read in, instead of reading it like this, right? We're going to have to find other ways of reading in our file. Now the file, if you look over here, should be available now, iris.csv. Okay, so it's available. All right, so how do we, so it should be in here. In the GitHub, this should be available. So in the example that I have in the GitHub, I used Pandas to read in. So that's great. Another very useful library in data science, right? So NumPy, Pandas, Matplotlib, you'll see them. So you guys actually pretty much have a good concept of Pandas already because you know a lot about SQL, right? So you do a lot of like SQL queries and things like that. So Pandas is kind of created in that fashion, basically. Okay, so I'm going to go ahead and see if I have Pandas available. So I'm going to go and try to import Pandas into my Jupyter Notebook. So we can go over here and say import Pandas as PD. All right, so this is a very, very powerful library. Okay. Okay, I don't have it available as expected. So then you guys know you can just do pip install Pandas. Okay, go ahead and do that. Give it a minute. All right, great. So it finished installing. No, you should always check this to make sure there were no errors. Then I usually just comment this out, but leave it in there so I can reference it. So then now invoke pandas. Look at the dot over here. That dot, there it is. So we have it available now. Perfect. So now we're going to use pandas. Actually, I usually use pandas to bring in data and process it. And then I usually convert it to NumPy for the final tweaks, and then maybe goes to Torch. So it's actually every framework has its own like data structure in the underlying C code, right? So you basically process things on Pandas initially, convert it to NumPy, and then usually it ends up in either Torch or something like that. But for our pipeline here, it'll start at Pandas and make it into NumPy. It's just something we have to get used to. And some people go to Pandas, NumPy, Torch, then NumPy, do something in NumPy, then back to Pandas. And as long as you do that right, it works. Okay, so we can comment this one out as well. We don't really need that anymore. And instead, now we're going to read in that data. Remember, the data is in the same current working directory, so we don't need to specify a path. So usually, things in Pandas are called data frames. Okay, so DF, data frame. You can give it any name you want, obviously, but I'm just saying that's a convention. And then you invoke PD, and then it's got a function called read CSV. Okay, so then we just need to specify the file. So in this case, it's going to be iris.csv. I believe that was the name of it. Okay, and did it have a header or no? You guys remember if it had a header or no? Don't remember? Let's see. Well, we can take a look. It does have a header. You can see sepal length, sepal width, petal length, petal width, and species. So we want to get rid of that header. And so Pandas will do that for us, should do that for us. So let's go over here and let's just specify header equal none. Okay. All right. So once we do this, let's go ahead and run this one. Okay, good. Let's do, I'm going to add a few cells in here. And let's do df.shape. All right, it's got 151. Huh. Well, oh yeah. So the header should be there in Pandas. We can look at the data frame actually, and you'll see that it should look much better. Pandas. There it is. Wait. Why did it not remove the header?
Because there's a,
Sorry?
I think it's because there's an extra, to go to the iris.csv file,
Mhm.
go all the way down, there's an extra, like an empty kind of color row. Check it, scroll all the way down. 152.
152, yeah.
So maybe when the header, it didn't remove the bottom, so that's what I think it's.
But it's still showing this though. It did show.
Okay.
Yeah, I still see that there. All right, so we got to remove that. Okay. How about header? Well, let's see. Yeah, I'll send header none. All right, let's see if it's a problem later. Because I will convert this to NumPy array, so maybe it'll just ignore it. All right, so let's try this. So now that we have the data in a data frame, what do we have? It's telling us it's got 151 rows. I really just want 150. So we got to figure that out. Then we've got 5 columns. So that means we need this to be the y vector. We need to, basically, we need to break this, right? We need to break it. I also need to convert these setosas and everything into numbers, right? So another problem. You see that this is all part of data science, right? So now let's see what we can do. We know, and you guys know from the word problems, that you always want X and Y. Right? Now in Pandas, we can also do slicing just like in NumPy. The way to do it should be df and then you do LOC. This LOC allows you to interact with the data through numbers. Because otherwise in Pandas, you can do letters like in databases. So for instance, I could say df species. Do you see that? Yes, I. If I took, so yeah, so this is why I find it so weird. I thought it was it's showing it, but it's not there. Yeah, you see, so yeah, go ahead.
Was it not like a page?
I don't know. I guess it's not there, but it's there, you know, so I don't know. We'll see.
Why to know that?
Huh?
Why?
You have to figure, I mean, you have to make it. So this is definitely.
I'm just saying, like down the road, like it's like, oh, I need this header, I need set to none.
Yeah. Because it's gotta be pure numbers, right? At the end of the day, X and Y need to be numbers, no more columns. You need to remember what they are, but you can't leave them in there for the machine learning. Okay, so that's the point. So here, yeah, good catch, right? So if I don't have the none, then this works. I have my pandas frame and I have this, right? And I can print out all the values. But let's set it back to none. So header equal none. Okay. So run this, run that, run that. This row, I mean, I could just slice it out if it's a problem. So this is why I'm not so concerned about it. This won't work anymore, so you can take it out. Get rid of that cell. Now, what I was saying is this pandas data frame could be sliced, right? So how do we do that? We can do just like we did with NumPy, right? So let's think of slicing in NumPy, right? So I want what? I want in X, I want this column, this column, this column, and this column, right? And in Y, I want this column. Do you guys see that? So how do I do that with slicing? Same idea as before. All the rows, remember? And then which columns? From beginning until what? Yeah. -1. Yeah, maybe. Yeah. Let's try 4, for instance, right? Let's just see what that gives us. So once again, x.shape is your friend. Okay. So go ahead. 151, 5. So it gave us still everything. So let's do then 3. Repeat it. There you go. Do you see that? So I have my data. So now let's confirm. Okay. The Y's are not there anymore, right? They're gone. Do you guys see that? This row is still bugging me. So a nice simple trick is that. You guys get that? So hopefully that gets rid of it. Gone. Does this make sense, guys? And we can confirm by printing out the shapes. is 150 by 4. This is the game usually in machine learning. Okay, getting those dimensions, getting the data to X and Y. You're literally doing that. Yeah.
But once you have that, it's just a matter of just running out the function.
Once you have X and Y, you know, then you basically think always of Weka. You know, you can just run it into Weka and run all those algorithms. As long as you get it into this X and Y form. Yeah. All right, so we need to do the same. Oh yeah, sorry. I just removed the row that was bugging me. Yeah.
So that one colon.
Yeah, remember, this is slicing, right? This is what we saw in the NumPy problems. So, so this reads all the rows from 1 until the end.
Okay, sorry, like, and then on the other end is split until the third column.
Right. This one is so before the comma is rows, and
Okay, I see it now.
and after the comma is columns.
No, it starts.
Yeah. Yeah. So this is just go back to the NumPy problems when we talked about slicing. I could have done 0 here, but
Are we coming back and that is spliced off, or in the Y, the last column?
mhm.
Are we going to go back and represent that values then?
Yes. I'm basically, remember, in the word problems, I said, what is X and Y? What is X and Y? But here we had to read all the data, right? When we read the data frame in Pandas, all the data is there. That's why it's 151 by 5. But usually in machine learning, you want to separate the X's and the Y's, right? So just like we did in the word problems. And so what I'm doing is, remember I said this, slicing is something you're going to do pretty much every time you're doing machine learning. It's one of the most common things for various things. We've done slicing, you know, here, and now I'm going to do this again for the Y. Yeah, please.
You prefer slicing over doing something like x equals df dot loop minus df species or something like that, using the names of the columns?
In Pandas, using the,
Yeah.
yeah, I prefer I mean, people have preferences, I guess. So if you want to use Pandas, you could select, so you're basically saying you would have done df dot species, right?
That would be your y.
And assign it to Y, basically.
Do like
Just do it like that. Yeah. Yeah, I mean, there's no right or wrong way.
I was just asking.
It's just my preference is to slice. Yeah, I have a tendency. I want to get rid of the header. That's the thing. Unless I'm doing some important, you know, like, so Pandas is extremely powerful. And I could say things like, I only want columns that include Virginica and Setosa, but not versicolor. So you start to get to that level, you obviously want to do that in Pandas. But at this point, all I need is X and Y. So I want to get rid of that header and just, you know, convert it into NumPy, basically. That's all I'm trying to do. Is this clear, guys? Making sense? Questions? All right. So yeah, so as I said, it's your first time doing this. We're going to do this almost every time. Okay. And sometimes you'll have images, sometimes you'll have, you know, different kinds of data sets. But the nice thing is it all becomes excellent. Okay. So now, all right, so I'll remove this one. So you guys should be able to, so we know that we confirmed that X is in good shape here. Now we have Y, and Y has a problem. So how do we get Y first of all? We could do df dot lock, right? And I'm going to slice it again. So I'm going to do comma. All right, so this should be what column?
You're only, so probably
Well, we can just look at the previous one, right? So we slice it until 3. So try 4. You can always just look at it also and confirm the values. And this should be what? All rows, except that we do have the problem of the first one. So we want to get rid of it. So we start at 1 instead of 0, right? So now I can do y dot shape. Run that. 150. Print. Y. And we've got our values there. Notice it is still a pandas. So we haven't converted it to NumPy yet. It's still pandas. We can probably confirm that by doing type. See if it tells us. Pandas object, right? We want it to become NumPy. So let's see what we can do. Pandas has a nice method because it's it's also an object. Dot values. Okay, let's go ahead and run that now. I'm gonna repeat this for, well, let's just run it for y. So I'm gonna run this, still 150 in dimension. But if I run type, what is it now? The NumPy array. It's now back to the thing that we started with this semester. So these libraries, Pandas, Torch, NumPy, they're all made in such a way that they know that you're going to want to go from one type to the other. Got it? Questions? Now let's take a look at this y. It says it's a NumPy. But there are still strings in there. So it's not numbers. So our job is not done yet. We have to convert this into numbers. Okay, yeah.
Just make like a simple, like,
Even better, we're going to use a built-in method that will do a lot of the heavy lifting for us. Okay, yeah. So let's do this for x. X should now be a NumPy array and be finished. So I'm going to go ahead and here. Yeah.
like if you were to do it.
You can do it, man. You can do it manually if you want, but it probably won't be as fast, and you could add mistakes in there. All right, so go ahead and run it. It's 150. Notice that it changed, right? The way that it outputs is now different. Pandas is more presentable, whereas NumPy is a little bit more like this. I always, why not check the data type just to make sure. Type, this is going to be X. NumPy array. All right, so we're getting there, right? So we've got our X and our Y, and I think a lot of it is looking good. This data type is not defined, however. Do you see that? It just says object. So data types, although this is Python, remember that the underlying is C. And so data types make an appearance again, okay? So here, let's actually add a cell, or here actually, and let's just do X equal X dot as type. And this assumes that this is a NumPy array, right? If it was a torch or something, you'd have to use a function for that. But in this case, I'm going to do float. All right. There you go. So now, yeah, it doesn't say anything, so it should be float now. Okay, should be good. NumPy array. Okay, but this one, we still have the problem that these are still strings, right? So that's the last step. We need to convert this to numbers. Okay, so basically here, I'm going to add a few cells. I'm going to add a a title here. I'm just going to call it split the data. Okay, and now we need to find a way to convert this into numbers. Okay, so we have a nice function in sklearn. So we're going to go back up here. So again, you can see sklearn. Although you can use sklearn for machine learning. It's got a lot of built-in machine learning model or algorithms, and it's easy actually to implement them, but it's not as powerful as PyTorch. For this, yes, it would be good enough. We might at some point try those, but in general, you use sklearn more for the pre-processing, and you leave the modeling for something else. All right, so we're gonna do from sklearn. You know, the reason why this is important is, let's say for some reason somebody you work for or whatever, they want you to build a machine learning model, right? So the first thing that's going to happen is they're going to give you some data. And you want to get the data to be X and Y all numbers, but it's probably not going to be like that. So you're going to have to go from whatever they give you to the X and Y in the way that you need it, right? And these tools that I'm showing you right now are what get you there, okay? So if you have labels with names, strings, you want to encode them, right? So we're going to use from sklearn pre-processing. From sklearn pre-processing, you're going to import something called the label encoder. Okay. So, oops, sorry, label encoder. All right, so let's run this to make sure we have it available. No errors, so that's good. So now we can go back down. And this is almost like it's an encoder, basically. It's a tool you can use. And we're going to apply it to this Y, okay? So that we can convert it. So I'm going to go over here. And I'm going to instantiate it as an object. So I'm going to do LE for label encoder. And it's going to be label encoder like that. So I create the object, right? And then I'm going to basically use it. So I'm going to say LE dot fit underscore transform. And what do you give to it? You give it Y. That's it. So basically, sklearn has these like standard functions, fit, transform as two separate ones. So you could give it the Y data, fit it on that data, and then you could apply it later and transform, or you have this built-in one, fit underscore transform together, right? But that's basically it. So it's gonna learn, it's an encoding, so it's gonna learn, okay, there's 3 words in there, Setosa, Virginica, and versicolor. I'm gonna create a dictionary of numbers 1, 2, 3, or 0, 1, 2, and boom. I'm gonna change it from words to numbers, and then you can reverse it if you want later. That's why you created this object. It's already trained, okay? So now let's see if it worked. So I'm gonna go ahead. I think I ran it. Done, right? Now let's go ahead and run LE, or sorry, not LE, Y. Done. You can check the type. NumPy, great. Check the length. Or the shape, actually. Let's do shapes then. Y dot shape. Okay, 150. X dot shape. 150 comma 4. Does this make sense, guys? So now you have your X and Y hopefully ready. So you're back at word problems, right? You just created your X and Y. It's ready. Now the next step because we want to train and test the model and you want to assess how good the model is, you want to do the split. So we go here, split the data. It's already ready to go. Got it? All right, so let's try it then. Okay, perfect. Done. Any questions? So I've shown you how to take a CSV file, any file, right? And as long as you understand the shapes, the number of rows, number of columns, you know, you can put the labels wherever you want, but usually in the end, right? And now you have the data, your 4 data sets that we're going to use to train. Any questions? All clear? All right, great. So yeah, let's continue. So now, what else do we need? So we have the data, X and Y. We have the data, we've managed to split it, it's ready to go. So I think we're ready to start the KNN algorithm, right? So let's go ahead and do that. We have to think about how this is going to work. All right, so let's just start thinking about this algorithm, right? So we have the data set here. So KNN, let's say run KNN. And then here I'm going to create KNN algorithm, say. Now, in Weka, you just invoked IBK, and that was it, right? That was already available. sklearn does have its own KNN object, but here the course, machine learning foundations, right, is about demystifying this and not being dependent on all these tools, right? So in this case, at least for this example, you're going to be implementing KNN from scratch. Okay, so that's basically the idea. I'm going to go ahead. So it's an algorithm. Okay. So we have to think about it. So let's say we're going to define a function. I'm just kind of like discussing it, and then we're going to fill in, right? So start with the overall logic, the things that we understand best first, and then drill down to more specific things. Now, keep in mind, a lot of these algorithms have a lot of efficiencies. We're using NumPy, so it's a NumPy approach. Obviously, you could probably implement this with a whole bunch of for loops and things like that, but just remember that's too slow. It's not going to be, for 150 samples, you might do it, but once you bring in 60,000 samples that are 784 in size, it won't be practical. Yeah, go ahead.
And you said that any operation you can do a bunch of for loops.
Basically, I did say that. I'm very bold at saying that, but I do believe it, yeah. Because I've seen it. Like, I'm not saying you can just give me some for loops and I'll make them matrix. But in general, I've seen very impressive things that I can understand in for loops, and somebody just came up with like matrix multiplications to solve. Okay. Yeah. So well, yeah, that's these algorithms that are very efficient and very powerful. They got these amazing tricks. Yeah. All right, so let's start thinking about this. So I'm gonna create a function, predict y. I mean, I don't know. All right, you can call it KNN, whatever you want, right? It's just some name. So we need to think of what's going to happen. So in a sense, we do need a for loop, right? We need a for loop where we take some test sample or maybe a batch of samples and compare it to the train set, right? That's basically what KNN does. Remember, like this room, right? So all of you are samples, and then a new student comes in. So you're going to compare that new student to all of you, right? Because it's a vector space of positions, you're going to take a distance between that new sample and all the samples in the space. So you guys are the train set. The new student is the new sample that you're evaluating. Got it? So that's the idea. So we need to have something like that. So how do we do it? So we need to basically for x in what? In X train. You guys see that? So X train is what contains the train set, right? So we want to build a general function where we compare a new sample to all the training samples. So do we have an X train? Yes, we do, right? We have it up here available to us. And then once we do this, okay, what do we want to do? We want to take this. So let's do 1, 2, 3, 4. We're going to take this X, right? And do what? Compare it against the new sample, right? So X train is all of you, and there's a new one coming in right here. And you're going to measure the distance between this and all of you. So all of you in the front obviously are the closest. And you guys in the back are too far, so it's more similar in terms of distance to the people in the front. Got it? That's what we're going to do. So we need to think of a name for it. So we can just call it test X, for instance. It just needs to be a name. You see that? But so the question is, what are we going to do, right? So let's call these just samples right now. What do? We need to take a distance metric between the test sample and all the samples in the train set. Do you guys see that? Does that make sense? So we need a function for that. So I'm going to create that function, and I'm just going to call it the Euclidean distance. And it is exactly the same Euclidean distance that you learned about in high school. Okay? Yeah, Henry, go ahead.
Basically, what we're doing is we're taking every element in X train.
Yes.
We're walking through all of the. Wait. I'm not sure where it comes from. Basically, your
Test X is just some new sample. Think of it that way. There's a new sample coming in.
sample, and you're trying to find which new sample is in the train set, right? And you're just finding which, I guess, like you're say that's like two numbers.
Yeah, right. So
Finding, like the distance.
yeah, we need to talk about that. So we need to talk about that. Yes, the representation of those X and test X.
You sort of close one and then return the label
Yeah.
of whatever. Okay.
Yep.
Would that be n squared complexity? Like you're basically looping through every time you're adding for every test you're doing.
Yeah, but we're not. Yes, you are right. The thing is, we're doing this in NumPy, so some of this can be done more efficiently with NumPy. It's sort of in parallel, if you will.
Okay.
But yeah, in essence,
It's not as bad, but
yeah, it's not. You're right. It's not as bad, but it's still not optimal. KNN is not the best. Also, another thing that's happening here is there is no training in KNN. Okay. In essence, there is just inference. We have the data set and we have new samples and we just compare. There is no training in KNN.
and to get the distance, you just want to do for each square.
We're going to talk about that in the next class, right? So I'm just laying out the machine learning pipeline right now. I'll give you some of the math on Thursday. Yeah.
What is the math? You're taking the math of the magnitude.
We're taking literally it's going to be the formula C square equals A squared plus B squared.
Yes.
If that answers your question. But we will drill down to all of that on Thursday. Okay. So today is just pipeline. Okay. All right. So we've got this idea of the Euclidean distance. So obviously this is a function that we're going to need to define. Okay. So for now, we're just going to call it Euclidean distance. And this actually can take generic things like P and Q, right? P, Q. All it does is it returns a distance between two samples. It just think of this scenario. I put somebody here, short distance, longer distance, really long distance. You see that? Probably the person that's the furthest from here would be over there. You see that? So just think of this function as returning a value of distance, okay? And this is based on the Pythagoras and all that. All right, so let's go ahead. Let's actually, to be consistent with the code that I have on GitHub, I called it V1, V2. So I don't want to define this today, right? Because I have to give you a little bit of background. We're going to discuss that on Thursday. But let's just imagine right now this returns, something, the distance. And I'm going to use that over here. I just want to do one last thing. But what's your question, Henry?
For this.
Yeah.
Your-
I'll cover this on Thursday. I'll give you like documents and things that I have for this. So today is just pipeline. We'll drill down in this. Okay, I'll give you all the math, I promise. All right, great. So the last thing I want to cover, guys, in Python, you may remember this or maybe you don't remember this, but we use a lot of list comprehensions, right? So you guys are familiar with list comprehensions? Do you remember what those are? A list comprehension in Python for lists? All right, so a list comprehension is, I have this for loop, right? This is the classic for loop that you've known for all your years, right, of programming. A list comprehension is a different way of writing these. Henry, I'm almost on time. So what we do here is, instead of writing the for loop like that, I'm going to write it like this. Distances equal square bracket, right? That's a list comprehension where I put for x in x train, right? And then I just put the bottom part in front. Like that. That's a list comprehension. Okay, maybe you haven't seen it before. You'll get used to it. And the reason is it makes the code nicer because it's just one line. But it's basically the logic is you put your for loop here, and then the x, which would have gone below, now is in front. So a way of simplifying this is like this. So I just do, I just do that, and then essentially what I have is a list of x's. This returns a list, okay? Do you see that? So let me do an example. So I'll do.
That would be the identity of that.
This creates a list. It's a list comprehension. So I'm gonna call it L1, right? And I do this like that. So what I'm doing is I'm iterating through X train, right? And then every value in X train, I'm plugging into the list. I'm adding it. It's like I'm adding it, and I'm creating the list in one shot. Okay, so then we can try something like L1. Do you guys see that this is a list? It's a list of, this is the vector of 4, then it's another vector of 4. You see the commas there. Does that make sense, guys? So that's a list comprehension, and that's something that we do want to make use of in Python, just to make it, to avoid these whole bunch of lines of code. It just makes the code longer. Okay, got it? Because then, not only do you have to do this, A equals something, but then you have to do L1 dot append A, and so it starts to get, that's already 3 lines of code. Okay, so the list comprehension makes that simpler. So we just got to get used to it. All right, so we're all out of overtime, 7:44. This is a good stopping point. Remind me that we got as far as predict, and I believe the Euclidean distance over here. Let me get rid of this because this was just an example. So on Thursday, I will start with the math, right? What Henry was asking about. You can start reading through it. It's already on Brightspace if you want to. We'll go over some slides and things as that, and talk about what a Euclidean distance is, Pythagoras and where all that comes from. And then hopefully implement our Euclidean function in Python and try to finish implementing KNN. All right, so my goal for Thursday is to get to the performance metrics with KNN. Got it? All right, please don't forget to work on your Weka homework, and we'll talk about when the presentations for that will be, okay? All right, guys, have a good rest of your day.